Now, all electronic devices like mobile phone, TV, or laptop, they need a constant DC voltage to be powered up. So these electronic devices, we use load to represent them. But to get this DC, our power source is AC, 230 volt from our power station. So this AC source is a very huge alternating current from our power station with positive, negative, and then is at 230 volt AC at 50 Hz. Now, with such a high AC power, we are unable to convert it directly to the working DC voltage. So we need this thing called the transformer. So the transformer that looks like this will convert the big AC and step them down to a smaller AC. And the one we use in the lab is 6 volt to 6 volt. Then we pass this small AC to this thing called the bridge rectifier. And after this bridge rectifier that is formed by these 4 diodes, the waveform will be a full wave. That technically speaking, all the waveform is in the positive DC zone. And this is full wave after the bridge rectifier. Now, we have this capacitor in the circuit which act like a filter. So after this filter, it will produce this thing called the pulsating DC, in which you will get the ripple. This ripple is very DC, direct current, but is still not usable yet. So we pass through this last thing known as the regulator to make it a constant DC voltage. And then finally, the voltage will be very consistently DC, example 5 volt, whereby the electronic devices can use. Now, one thing to take note is that when there is a filter here, technically speaking, the full wave don't exist, because the capacitor will store the charge and discharge slowly and make the full wave to become the pulsating DC, also known as the ripple. So if the filter capacitor is there, technically speaking, there will be no full wave, and the pulsating DC is in the form of ripple. And after the regulator, it will become a consistent 5 volt DC.